folks? Looks like Dalton was a pretty smart guy, huh? He not only used the laws of chemical combination to propose the first atomic theory and give specific symbols for elements, he also proposed the concept of atomic mass. Yes, atomic mass refers to the mass of one single atom. And he believed that every element had a characteristic atomic mass. But think about it. If atoms around us are so small that they are completely invisible, how heavy could they actually be? I'm sure most of you would say very, very, very light, obviously. And you would be right. Now, I know you're wondering what isotopes are, right? But you see, talking about isotopes now will take us completely off our topic of atomic masses. But don't worry, we'll talk about them in detail, like what exactly they are, how do we represent them, and so on in the next chapter. For now, simply understand that isotopes are the different forms of the same element that have different masses. For example, naturally occurring oxygen present in air has 3 isotopes: oxygen 16, oxygen 17 and oxygen 18, out of which oxygen 16 is the most abundant one. As you can see, all these 3 isotopes are of the same element, oxygen, but have different masses. Similarly, among the many isotopes of carbon, carbon-12 is the most abundant one that accounts for almost 99% of the naturally occurring carbon. Therefore, the atomic mass of an element can be defined as the relative mass of its atom as compared to 1/12 the mass of one carbon-12 atom. To make it simpler, this is like taking a watermelon and slicing it into 12 pieces and determining the masses of other fruits with respect to this one piece. For example, the atomic mass of sodium is 23U, which means one atom of sodium element is 23 times heavier than 1/12 the mass of a carbon-12 atom. So another interesting concept, let's quickly revise what we learned so far. Atomic mass is the mass of one atom of an element. Atomic mass unit is expressed as AMU or U.
We'll cut the minor segment formed by the chord AB and try to paste it on the minor segment formed by the chord CD and see whether it will exactly fit in or not.
Hello guys, how's it going? Did I say conducting liquid? Do liquids also conduct electricity? Well, apparently, yes, they do. Now, in the circuit, we have a 9-volt battery, a switch, an LED bulb which glows even when small amounts of current flows through the circuit, and a container containing water. Now, you can see that the wires going inside the container are not really touching. This means that if the bulb glows after closing the switch, it is conclusive evidence that current can flow through liquids. Petrol, kerosene, honey, cooking oils, and glycerine are some examples of liquids that are bad conductors or poor conductors of electricity. On the other hand, tap water is a decent conductor of electricity because of various minerals and salts dissolved in it.
So in the last video, you saw the difference between simple interest and compound interest, right? So quickly tell me the difference between the two. Well, if the interest is the same throughout the given time period, then it is simple interest. And if the interest keeps increasing over the given time period, then it is compound interest. Yes. Principal for the next year will be the amount of the previous year. So what was the amount in the previous year? It is P into 1 plus R by 100 whole power 1, right? So you should calculate the interest on this amount. So this amount will be the principal for the next year. Now principal is P into 1 plus R by 100 whole power 1. Time period is 1 because we are calculating only for 1 year, which is second year, right? Rate of interest will be R. So substitute the values in the formula. I is equal to PTR by 100. Now let this be I2 because this is the interest that we are calculating for the second year. Now it is P into 1 plus R by 100 whole power 1 into 1 into R by 100. So I2 will be P into 1 plus R by 100 whole power 1 into 1 into R by 100. Now what is the amount? So A3 is equal to P into 1 plus R by 100 whole power 3.
You said that you will tell the shortcut. But what are these calculations?
This is where exactly the students will lose patience. Now what is the amount that is to be paid after 3 years if the interest is compounded annually? Well, simply substitute the values in the formula. Let's quickly summarize on what we have learned so far. If the interest is the same throughout the given time period, then it is simple interest.
So today, we'll be applying a layer of copper metal on top of an iron nail using the method of electroplating. Now set up the circuit as we usually do. We connect one end of the switch to one of the terminals of the cell and connect the other end of the switch with a free wire. Now here, like copper wires or copper plates. But once we are done connecting the iron nail and the copper rod, we need to immerse both of them halfway into the container which contains the copper sulfate solution. Now ensure that your switch is in the open position while you're performing all these activities to avoid any accidental flow of current. Now let me turn on the switch, let the current flow, and let the electroplating process begin. That we have taken copper sulfate solution here. Now copper sulfate is a salt of copper. But the question is, why just the salt of copper? Why couldn't we take the salt of zinc like zinc sulfate or a salt of magnesium like magnesium sulfate? Well, the answer to that is simple. Because you are depositing copper on our object, we are using the copper salt, which is copper sulfate.
So friends, can I expect that you have a good command on the identities? Instead of writing 103 into 105 as 100 plus 3 into 100 plus 5, can we rewrite this as 100 plus 3 into 99 plus 6? I would say no. Why? To relate this with our identity x plus a into x plus b, we should make sure that our expression should have at least one common term in both the factors of the expression.
What do we know about nucleus till now? Well, we know that nucleus is a very small, highly dense, positively charged part at the center of the atom. Now, before moving on, let's take a quick look at the periodic table here. So, what do you guys see first here? Just like protons, neutrons are equally important and provide us with another crucial information about atoms, which is the mass number. Mass number is the total number of protons and neutrons present in one atom of an element.
Is geometrically represented by a line such that every solution to the linear equation is represented by a point on the line, and every point on the line represents a solution to the linear equation. Finally, a point which is not on the line will not be a solution to the linear equation in two ways, since we need only 2 points to find a unique line passing through those 2 points. So, we have to find 2 solutions, and that would be enough to draw the graph of this linear equation in 2 ways. And what's given and what we have to find. Here, it is mentioned that 2, 14 is a point, and there are 2 distinct lines passing through that point. Now, we know that if a point is lying on any line, then that point is a solution to the linear equation represented by that line.
Hi Rachel.
Hi, Kirti.
I'm sure you're aware about the science exhibition that we have coming up, right? So, what your students are planning to make?
Well, Kirti, Joy from my class is going to make a living robot which can dance and play with him. And he plans to make this robot also console him when he's sad.
Oh, that's an awesome idea. But I think the word living is a problem here.
Why, Kirti? I mean, if it can respond to his queries, then it can be considered living, right?
Well, no matter what all qualities does the robot created by Joy has, it will always be considered a non-living thing and never a living being.
I'm confused here. Can you please explain this to me in a little more detail?
Yeah, sure I can. Well guys, let us understand the differences between living beings and the non-living things in detail. And I hope by the end of this session, you will have all the answers to the questions, what are the differences between living beings and non-living things. So guys, let us find out whether the creation of Joy will be a living being or a non-living thing. Well, this must have kept you thinking at times, how do we differentiate living beings from non-living things? Let me tell you, it is no rocket science and it is really simple. What I mean to say is that there is a set of certain basic characters based on which we can differentiate the living beings from non-living things. But plant growth is quite different from animal growth. A seed, if provided with moisture, nutrients and sunlight, grows into a plantlet, a plant, and some plants in due course of time grow into trees. But if we talk about the robot that Joy mentioned, it will never show growth. as it is not a living organism, since taking place inside the body of the organisms, which include both make-up and break-up reactions. The make-up reactions like formation of energy are known as anabolic reactions, whereas the break-up reactions like breakdown of glucose are known as catabolic reactions. And the sum of these anabolic and catabolic reactions are combinedly known as metabolic activities. These metabolic reactions take place only inside the cells of living organisms. And again, if I talk about the robot, then it will work on energy externally provided through batteries. No energy formation can ever take place inside the robot's body. For example, this tiny bacteria rapidly multiplies its population and converts the milk into the curd. This rapid multiplication of population is basically reproduction. In the same way, other living organisms like plants and animals also reproduce as they produce young ones. So, we can say that reproduction is another essential feature of living beings. But robots can never exhibit reproduction. I'm talking about movement here. If we see an animal moving, we know it is alive. In simple words, we tend to think movement as a common evidence for being alive.
Hello everyone, I hope you did a thorough revision of the last video where we studied about one of the measures of central tendency, which is mean. The mean or average of a number of observations is the sum of all observations divided by the total number of observations, and it is denoted by the symbol x bar. Also, when the data given is large and we can write it in the form of an ungrouped frequency distribution table, we use the formula mean is equal to summation fi xi divided by summation fi. We use the letter sigma for summation. Replace the observation 40 by 12. So, if we remove the observation 40 from this sum and insert 12 at its place, the new sum will be 340 minus 40 plus 12, because removing means subtraction and inserting means addition, right? The new mean. Sounds confusing? Do not worry, I will simplify this for you. Each term essentially means we are adding the same number to the mean as well. So guys, this was all for today. Practice as many questions as you can to master this concept. See you in the upcoming video. Till then, goodbye.
Gold and silver. Now, do you think they could melt the metals if they use the middle and inner zones of the flame? What do you think? Actually, no. And this means that the flame is not uniformly hot. Precisely why, when you introduce a glass plate into the luminous part of the flame, it produces a blackish ring. The blackish deposit on the glass plate is nothing but the unburnt carbon particles. Now, the outer zone is the hottest part of the flame. And due to the availability of plenty of oxygen, complete combustion of the fuel or the wax vapors take place. If we provide an artificial supply of air, like in a spaceship or a spacecraft, it would definitely burn. But then again, do you think it would burn in the same way as it burns here on the Earth? In a spaceship, the candle burns with a round-shaped flame instead of a tall standing flame. But why does this happen? Well, you see, due to the significant gravity on the Earth, the convection currents around a burning flame are generated in this fashion.
So in the last video, we saw how to find the median using graphical representation, right? Now in this video, let us take a look at some problems on this median. Let's go. Come on. The first problem is, find the median if the mode is 12 and the mean is 15. Well, I must tell you an interesting relation, but take a moment and give it a try. So what we are supposed to do? Well, we are supposed to convert this grouped data to a less than type. Frequencies on the graph and join the points. So 12 here, 26 and so on. So this is the OG for the data of less than type cumulative. Well, pause the video for a moment and give it a try. Now note that 50, 55, 60, 65 and so on till 75 are the lower limits of this grouped data.
Hi everyone. So far we we discussed a number of methods that were used to separate different types of mixtures. Like, we know that to separate a mixture of iron filings and sulfur powder, all we need is a simple magnet. But what if we heated this mixture? Do you think the mixture would still get attracted to the magnet? Well, we know that when we heat this mixture, we get a new black substance that does not get attracted to the magnet anymore. Well, you can see that the products obtained before and after heating have very different properties. For instance, in the first case, we simply had a mixture of iron filings and sulfur powder. And here, the change was pretty much a physical change. Whereas, in the second case, that is on heating, the iron filings combine chemically with the sulfur powder, producing a new compound, the black substance. Gold ornaments of different shapes and sizes. But in the end, they're all still made of gold, right? Forms of water. Yes, water vapor, water and ice. Do you think that vaporizing water into water vapor or condensing water vapor into water or melting ice are examples of physical or chemical changes? Well, turns out they're all again physical changes. You see, in all these forms, the chemical composition of water remains the same. That is, no new substance is formed in any of these changes because water vapor, water and ice all still contain 2 atoms of hydrogen and 1 atom of oxygen. Hence, the composition of the substance changes. A chemical change, otherwise called a chemical reaction, always produces a new substance. Obviously, the properties of this new substance will be different from that of the original substance, right? Now, lighting an incense stick, burning of wood, cooking food, rusting of iron are all examples of chemical changes. Let's take burning of paper for instance. When we burn paper, new substances like carbon dioxide, water vapor, smoke, and ash are produced. Similarly, the vegetables before cooking look, smell, and taste different from the cooked vegetables, right? This is because on heating, the organic substances present in the vegetables undergo chemical reactions and break up into different substances. I hope you had a great journey learning about some interesting concepts, separation techniques, a brief introduction into elements and compounds, and so on.
Hello guys, how's it going? In this video, we are supposed to talk about the basics of friction and in a way reintroduce the concept of friction because vibration essentially means motion of one object with respect to the other object. So imagine that there are 2 cars going together on a highway at the same speed, and in this another example. Consider 2 books, book A and B. Now if I try to slide B on top of A on a rough road, you see in that case friction becomes so high that even after applying all your muscular force, the block barely moves. Similarly, before playing a game of carom,
Is actually an alloy of copper and zinc. Now, did you know that brass was extensively used in medieval Europe? Yes. Now, in a solution, the substance present in less quantity is called the solute, whereas the substance present in larger quantity is called the solvent. Now, similarly, air is also a mixture of several gases. Some other examples of solutions are salt solution, copper sulfate solution, a solution of iodine in alcohol also called tincture of iodine, vinegar, which is nothing but acetic acid in water, aerated drinks, lemonade, and so on. In all these examples, you can see that the components of a solution are uniformly mixed throughout without having any boundary of separation between them. That is, in a solution, the particles cannot be distinguished from each other. And this is what makes them homogeneous. So now you know why solutions are homogeneous in nature. But why they called mixtures? You can see with their naked eye without any assistance is only about 0.1 millimeter, which is 10 per minus 4 meter. And that's about the thickness of the human hair. So clearly you can see that the size of these particles is about 100,000 times smaller than the human hair. So I guess now you can understand why sugar crystals perfectly visible in our hands become invisible or undetectable in a sugar solution. The size of the solute. You see, the average pore size of a filter paper is about 10 micrometers. But as we just discussed, particles are uniformly mixed. Nothing really happens to it even if we leave the solution undisturbed for a while. suspensions, and collides of particles of much larger size.
Hi friends, we have come a long way in the chapter thermodynamics. We have talked about the first law of thermodynamics. We talked about the zeroth law of thermodynamics. So what do you think is next in the order? Well guys, if you are thinking second law of thermodynamics, you're absolutely correct. But guys, before getting into it, the first thing that comes to the mind is, why do we need to study it? Well guys, this law, now if we have to write it mathematically for both the processes, that is the reversible and the irreversible process, we even did that in our last class. Do you remember that? Well, that's what we are going to follow up again, and we have to write the same thing. Now we talked about it in the previous class, that how to write the entropy in terms of heat change. How did we do that? We simply said that ds can be given as dq upon t. Now I have one little question for you. Do you guys remember how do we give the mathematical statement for the first law of thermodynamics? Think about it guys, we have done that. Okay, let me tell you. So we can say that dq is equal to du plus p dv. We have done this derivation. So do you see something new that can be replaced? Well guys, if you are thinking about the change in heat dq, you are absolutely correct. Because we just did that dq that can be written as tds. So overall the equation can be written as tds is equal.
Hi guys, welcome to another amazing video of this chapter. You already know about parallel lines, transversal, and the relation between the angles when a transversal intersect parallel lines, right? When a transversal intersects two lines, some special angles are formed. They are corresponding angles, alternate interior angles, alternate exterior angles, and interior angles on the same side of transversal. We know that lines are parallel if they are always the same distance apart and will never meet. So firstly, draw two parallel lines. You know that the ruled lines of your notebook are parallel to each other. So with a ruler and a pencil, draw two parallel lines along any two of these lines. And then draw a transversal to intersect them. Then name the angles like this. Now let's measure any pair of corresponding angles to find the relation between them. Let's start with angle 1 and angle 5. Both these angles are equal. Let's take angle 4 and angle 8. These two angles are also equal. Conversely, if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So guys, this was all for today. Now let's do a quick recap. A line which intersects two or more lines at distinct points is called a transversal.